Earthworms. They seem so small, so inconspicuous, and even uninteresting to the human eye. But these worms are the key to my research on the environment. My name is Yuya Hayashi. I'm a nanoscientist working on my PhD at Aarhus University. I study how nanoparticles can have an impact on the environment. Are they good or bad? And how do nanoparticles affect the well-being of small animals like earthworms? You may wonder, what are nanoparticles and how can they end up in nature? Nanoparticles are very small particles, generally less than 100 nanometers. The size of a typical nanoparticle is to a football as a football is to the Earth. Nanosiver is one type of nanoparticle. It is used as a new antibacterial material in a variety of modern consumer goods, socks for instance. However, even your antibacterial nano socks will get smelly and need to be washed someday. Nanosiver released from your socks will travel through the sewage pipe, and research suggests that some of the nanosiver particles will end up in nature. Now, is this good or bad? Well, the worst case scenario can be something like this. A copper-polluted site with patches of no vegetation and no worms. In the case of nanosiver, we simply do not know the answer yet. What we do know is that nanosiver products are sold increasingly every year without anyone actually knowing the environmental consequences. That is why I study its impact on earthworms and how it affects earthworms' immunity. These guys are the main players of my experiment. This yellowish solution is nanosilver, or to put it in another way, with the naked eye, the color is the only way we can tell that it is.
Yeah. Okay.
I think I need to look at to be sure if it's actually nanosilver.
Exactly.
We need to see the particles using what is called an electron microscope. Size is an important parameter because if they are large, they are not nanoparticles. But how small is also critical because 10 nanometer and 100 nanometer of the same nanoparticles may have completely different toxicity to animals. Well, it looks like my nanosiver has a size of about 20 nanometer. This is a bit larger than an average protein. Now, I want to know how my nanosiver behaves in a new environment. If nanosiver is put in an environment rich in salt, it clings together and aggregates. When it aggregates, it loses its nice yellowish color because it is no longer a nanoparticle. So I need to make sure that my nanosiver behaves itself and can be used for my earthworm experiment.
Yeah, sure.
Doing science is a real teamwork, and I need a helping hand from my colleagues. It seems like my nanosiver is doing well. Finally, I'm ready for my experiment on earthworms. First, I need to get the immune cells from the worms in order to treat them with nanosilver. This can be tricky. What I do is I make them drunk with a bit of alcohol. It looks like they're dancing, or so I believe. I have to confess that I have already had a number of dreams about worms dancing. Eventually, they start to throw up, or in a scientific word, extrude cells. I then put the cells in this special culture plate. The cells are now in a nutrient-rich culture medium free from alcohol. Finally, I add my nanosilver or water for comparison. I then have to wait for 24 hours before I make analysis on them. And the drunk worms? Don't worry, I always put them back in their home soil and soon they will recover from their hangover. Now comes the moment of truth. Will I have useful data? This is so essential in doing research. More often than not, something goes wrong and you have to do the experiments all over again. This time I'm lucky. I can see plenty of cells and lots of them are dead. This is in fact an indication that my worm cells have eaten nanosilver particles, and some of the cells are actually committing suicide. This result shows that the nanosilver can kill the earthworm cells in a test environment. In the next step, I will definitely need to check on the earthworms out in nature, but that will be tomorrow. Doing a PhD is far from a one-man show. Without help of good colleagues, nobody can perform good science. That's why, if my experiments don't work out, I feel like I have wasted their time. During the daily coffee breaks, we discuss our projects. We share the failures and of course the happiness of discovering something new in the world of science. For me, this happiness is a driving force to do science and the motivation for doing a PhD study.